Okay, the last section of this chapter is on circular motion or on torque and simple machines. So think about a doorknob, and they come in different styles. What style of doorknob is easiest and why? Okay, and then list the name of any of the simple machines you can think of, and what's the purpose of a simple machine? So we have two different kinds of motion, rotational and translational motion. Consider a tire moving on a car. Translational motion is the movement of the center of the mass. So it'd be more of a linear motion where the tire is going from point A to point B. Rotation is the motion of the movement around the axis as it's going around and around the axis. It occurs around the center. And the changes in rotational motions are caused by torques. And a torque is the ability of a force to affect the rotation. So it affects rotational motion. So where should the cat push on the cat flap door in order to open it the most easily? As you know, as from experience, it's from the bottom, as far away from the hinges as possible would give you the easier open. Think about also if you're opening a door in the classroom or at your house, it's easier to open it and push on the farthest away from the hinges than really close to the hinges. You get the most movement out of the force that you're applying. So the torque depends on the force and the length of the lever arm, which is D. So here, think of this as the door. The force and then the lever arm is how far the force is applied from the axis of rotation. Torque also depends on the angle between the force and the distance. So if you have a force that's perpendicular versus an angled force, which one will give you the most torque? Which one's able to produce the most motion? Or think about if you're opening a door, do you push on it perpendicular to the door at an angle? Which one gives you the easiest to open the door? It's the perpendicular motion force, because all of your force is going in that same direction, where here, if you're applying it at an angle, now some of your force is being applied at a different direction. Think of XY axes, and so you're not getting as much force. So here is our equation for torque. T, and this is actually tau, it's the Greek symbol, but we'll call it T for now, is equal to force times the distance, the lever arm, times the sine of theta. Now, if you are pushing perpendicular to the door, sine theta is going to be sine of 90, which is 1. So we just have torque is equal to force times the lever arm. Torque is not joules because it's not an energy. The quantity d, sine theta, is the perpendicular from the axis to this direction of the force. So here they're showing this is if you extended your force and your axis of rotation, this is your d sine theta. Okay, torque has a direction. It's positive if it causes counterclockwise rotation and negative if it causes clockwise rotation. So are the torques shown to the right positive or negative? This force is going to cause a counterclockwise, so that one probably is positive. This force is going to cause a clockwise rotation, so that should be negative. Yep. The net torque is the sum of all the torques on that system. Okay, so suppose the force on a wrench is 65 newtons and the lever arm is 20 centimeters. The angle between the force and lever arm is 35 degrees. Calculate the torque. So our equation is F d sine theta. So let's write out our numbers. We have F d sine theta. So we'd have F, the force is 65. The distance, now we do need it in meters, so it's 0.200 meters, and then sine of 35. We should get 7.46, excuse me, 7.46 Newton meters. What force would be required to produce the same torque if the force were perpendicular to the lever arm? So if it's perpendicular, that means sine theta, sine 90 is 1, so we'd have 7.46, that's our torque, because we want the same torque. We're looking for the force, and the distance is not going to change, so we have 0.200. So our answer would be 37.3 newtons. Simple machines can change the size or direction of the input force, so you're inputting force and you're getting out a certain amount of force. It's going to make your force that you're inputting more efficient. So mechanical advantage, it compares the input to the output force. So when your output force is greater than your input force, then the mechanical advantage is greater than 1. It's basically showing you how efficient your machine is going to be. Mechanical advantage can also be determined from the distances. So we can take the force divided by the input to give us our mechanical advantage, or the distance versus the distance out. So how far you move the machine versus how far the machine moves the object, basically.
Force. A simple machine changes the direction or amount of a force. Simple machines include levers, wheels, pulleys, inclined planes, wedges, and screws.
Okay, so how many of those did you guys get when we, at the beginning of the chapter? So simple machines alter the force in the distance moved for an inclined plane. So F2 is less than F1. So if you're trying to raise this object up on top of this trailer, your force is going to have to be longer here. So the force, you need more force here than here if you're taking the inclined plane.
There is a tech committee meeting going on right now in Mr. Chechela's room.
But you have increased the distance. So if you want to decrease the force, you have to increase the distance for an inclined plane. If the ramp is frictionless, the work is the same in both cases because your force times distance, since your force in bigger and smaller distance in the first case, but you have a smaller distance and larger distance, or smaller force, larger distance in the second case. With friction, you're going to have a little more work. Okay, you can also look at the efficiency of the machines. It measures the work output compared to the work input. In the absence of frictions, they're equal. So real machines have efficiencies less than 1. You're not 100% efficient ever. So your output is less than your work input. So think back to your doorknobs. What is the easiest to use? And you should be able to name the simple machines and what the purpose of a simple machine is.